Hello and welcome to our review of solving systems of equations. We're going to solve systems using three methods: graphing, substitution, elimination, and then we'll quickly talk about some special cases. The basic steps for graphing to solve are going to be graph both equations, identify where the two equations intersect, and then create the ordered pair. That will be the solution. So if we look at this equation, this system of equations here, we can graph the equation y equals x minus 1 starting at negative 1, going up 1 over 1, up 1 over 1. The blue equation, the bottom equation, starting at positive 3, go down 1, right 1, down 1, right 1. What we see here is we have the coordinates 2, 1, so x is 2, y is 1. If you plug in a 2 for x in the top equation, you get 2 minus 1, that's going to equal 1. That works for y. Plug in 2 in the bottom equation, negative 2 plus 3 equals 1. It works for the blue equation as well. Why don't you try this one on your own, hit pause. Okay, now you've had a chance. Let's go ahead and look at the top equation here. Starts down at negative 4, goes up 2 over 1, up 2 over 1. The green equation starting at positive 5 will go down 1, right 1, down 1, right 1. So if we look at our solution, it's going to be this spot right here. Has coordinates 3, 2. We plug those in, and that's a good idea to do. You get 6 minus 4, which is 2. You get negative 3 plus 5, it's 2. It works as a solution. Let's try the other method, the next method, substitution. First step is to solve one of the equations for a variable in terms of the other. It's going to be an expression then. We'll substitute that expression into the other equation and solve it for that variable. We'll get a number there. And then the last step is to take that, substitute this numeric value of the variable into an equation and solve to determine the other variable. Well, that sounds quite wordy, but when you see it happen, it should make some sense. So out of this 2, we'll get like x equals 4 or something. Plug it into the second or one of the equations, solve for y, something like that. So we'll start with this one here. We have x already solved for an expression, y plus 1. So we'll take that, plug it in for x. We get 2 y plus 1, which is what x equals, minus y equals 5. Distribute, we get 2y plus 2 minus, and you might want to put a 1y there, equals 5. So our like terms, a 2y and a minus 1y, combine to get just 1y plus 2 equals 5. Undoing plus 2 with minus 2, we get y equals 3. Okay, this is the end of step 2. Basically, we've substituted into the expression and solved. In this case, we've gotten y equals 3. Now we can choose either equation to plug into. Typically, it's easiest to plug into the one that we had the expression for. So this simply turns into 3 plus 1, which is 4. Our answer is 4, 3, remembering that x is the first number in the ordered pair. We could have plugged it in, a little more work. We could have plugged in y equals 3 here. We'd have gotten 2x minus 3. You can add the 3 over and get an 8. 2x equals 8 will give you the same solution for x to equal 4. All right, try this second one on your own and see how it goes. Hit pause. All right, you should have noticed that the y was already solved. We can substitute that in. We get 2x plus negative x plus 5 equals negative 4. We don't have to distribute anything here. It's just a plus 1 there. So we get 2x minus x, or 1x, plus 5 equals negative 4. Combining, we get x plus 5 equals negative 4. And x equals negative 9 when you subtract the 5 from the negative 4. Okay, we're halfway there. Plug this into either equation. I would choose this one. Negative 9 is going to be positive 9. So we get 9 plus 5, which is 14. Our solution is negative 9, 14. And we can check this solution plugging in, let's say, to this top equation. We would get negative 18 plus 14, and that's going to equal negative 4, and it works. All right, our final method is called the elimination method. We're going to choose a variable to eliminate, create an equal and opposite coefficient by multiplying one or both equations, add the two equations together, and solve for the remaining variable. This will give us just a numeric value for one of the variables. Substitute that in, and we'll get our solution. If we look at this first one on the left, we have opposite coefficients for x but not equal, and then we have equal but not opposite for y. I'm going to choose to multiply the bottom equation by a 2. That gives me negative 2x. And when I multiply the whole equation, of course, I have to multiply across everything. Plus 2y equals 2. Bring down our top equation. That's a positive 2x plus y equals 4. If we add these, we see the x's eliminate, and we get 3y equals 6. And in this case, we just divide by 3. Y equals 2. This is our step 3 here. We've added and gotten the remaining variable solved for, in this case, the number 2. We can plug that into either equation. We'll plug it into the top here. I get 2x plus 2 equals 4. Subtract 2. You get 2x equals 2, which is x equals 1. That makes our solution 1, 2. All right. And we can double check that. I mean, you can plug this solution into the bottom equation, make sure it works. Negative 1 plus 2. Negative 1 plus 2 is 1. 1 equals 1. So that's a great solution. Why don't you try this one on your own? Hit pause. Okay, in this situation, it becomes kind of obvious to me that I'm going to multiply the top equation by negative 2 because the x's are not going to be easily eliminated. So if I distribute the negative 2 all the way across, my y coefficients are equal and opposite. Remaining value then is negative 1x, or negative x, equals negative 4. If I divide by negative 1, I get x equals 4. Take that value and plug it into either equation. I think the top one's the easiest. 2 times 4 is 8. So I get 8 plus y equals 2. Subtracting the 8, I get y equals negative 6. So my solution is 4, negative 6. And to double check that, we can plug in here. In the green equation, we would get 12, and then 2 times negative 6 is negative 12. 12 minus 12 is 0, and of course we made it work in the top equation. So good solution there as well. All right, last thing to discuss has to do with what's called special cases. In this case, we're going to have no solution or infinitely many solutions. And watch what happens here. We'll use the elimination method here. We have equal but not opposite. So I'm going to multiply by negative 1 here. I get a negative 2x minus y equals a positive 4. When I add these together, not only does the x variable eliminate, but so does the y. So I end up with a 0 equals 9. This is an untrue statement. Therefore, we have no solution. If we look over at this system of equations, I can multiply the top by negative 2 to get negative 4x minus 2y equals negative 8. Again, variables eliminate, but in this case I get 0 equals 0. We would say in this case it's the same line, and so every point works, and we get infinitely many solutions. All right, and just to show you that, I'm going to go ahead and graph these, and you can see that when we have infinitely many solutions or no solution, there's a fairly common looking graph. Here we go. So if I just subtract the 2x over on these, I get y equals, that's kind of handy. I go down to negative 4, 1, 2, 3, 4. It's down to right 1 or up to back 1. And for the blue, I'll get a different pen here. For the blue, we would start at 5. 1, 2, 3, 4, 5. Down to right 1, down to right 1. And you can see my lines are going to be parallel lines. That means no solution. Okay, they'll never intersect, so they never have a point of intersection. Come over here and do the same type of work. I get minus 2x, so y equals 4 minus 2x. Subtract the 4x and divide by 2. I get y equals, y equals, divide by 2. I get y equals 4 minus 2x. If you have y equals 4 minus 2x for the top equation and y equals 4 minus 2x for the bottom equation, clearly you've got the same equation. So we're going to have every dot working for both of those equations. I hope that helps. Make sure you go through your homework or your mastery work and your notes and ask questions in class. Good luck on the test.